Our bodies are driven to a great degree by the brain's pleasure center. We find enjoyment in eating, drinking, interacting with loved ones, and recreational activity. Tampering with this part of the brain through drug use and other unwholesome activities can cause a troublesome turn in the brain's reward pathway, resulting in unhappiness and addiction. Brigham Young University's Dr. Scott Stephenson and his team of students from the Department of Psychology and Neuroscience recently collaborated with the University of Toronto on a study that takes a closer look at how the brain can switch to an addicted state without drugs.
The general purpose of the reward pathway is to have us be able to like doing things that are good for us. And so the reward pathway, when you stimulate certain neurons, they release a chemical that says, okay, this is pleasurable, this is something that's good, and I'll keep doing it. That's how basic in functioning that it is. And what drugs do is they mimic those same chemicals, and then they'll kind of explode them into levels that are not normal. So after that, your brain's trying to play catch up.
Brain-derived neurotrophic factor, or BDNF, is a naturally occurring protein in the brain and aids in the brain development of infants. Throughout life, BDNF remains active in areas of the brain that are vital to learning, memory, and higher thinking. To better understand the role of BDNF in the brain's switch to addiction, BYU and Toronto teams worked with rats, who are easy to handle and whose brain is wired much like a human's. The teams discovered that in rats that had received opiates only a few times but were not yet addicted, an injection of BDNF was what caused the animal to exhibit addicted behaviors. By administering opiates, researchers caused rats to give up a comfortable environment in exchange for one less desired.
And it's only because they're feeling something with morphine, and so they know that they like it, and they stay in the environment even though it was not their preferred place.
When BDNF levels increase, normally neurons that are the brakes on the reward pathway switch to becoming the accelerators.
Researchers believe that this brain adaptation involving BDNF puts the individual in a diseased state, and that compulsion-causing stimuli involve not only drugs, but also visual stimulus disorders like pornography. It is believed that anything unnatural that overwhelms the system may lead to dependence.
There are all sorts of drug users out there who know that they're addicted and do not want to be addicted anymore. So they're looking for a way to rehabilitate themselves, to recover from that addictive state.
Yes, it's sometimes a stupid decision, but they're taking it because it feels good. And the problem here, though, is their brain has changed with chronic abuse. Understanding how the switch happens in the brain may suggest possible therapies, whether they be medical or otherwise. And hopefully, we'll find a way to get that change, that switch, to switch back, and then hopefully they'll be able to take hold of their lives and be able to have the power necessary to overcome this thing.
A critical step for the team now is to better understand how other molecules and processes are involved in the addiction switch. Though there is much work still to do, the team is certain their abilities are equal to the task.
BYU is extraordinary because they have this mentored learning, mentored research opportunities. And I don't know any other undergraduate university that is so large that gives so many students opportunities to work with a professor one-on-one and to be able to do research that really matters and research that will get published.
It's definitely fairly unique that undergraduates work in laboratories and like, you know, JD over here is doing an experiment, and he's a, what are you, junior or senior? I forget. Junior. And ordinarily you wouldn't have that.
Good science often requires collaboration. Cooperation between Brigham Young University and the University of Toronto allows students to strengthen their ties scientifically with the outside community, while at the same time making discoveries that will impact humanity. Jordan Harker, BYU Weekly.